So I'm aware, well, try not to fall off the back of the stage. I'm aware there's been quite a bit of discussion on Slack about, is it possible to fit a deep dive into Sendable in 30 minutes? I'm going to try my best and cover as much as I can, but I will be available afterwards for questions, so feel free to ask. So I'm going to give you a bit of an overview of Sendable, and hopefully by the end of this talk, you'll have a good idea of why Sendable exists, what exactly it is, and how you can use it to write safer code in your apps. So if you've never met me before, I'm Tim. I run a company called Broken Hands. We do server-side Swift consultancy and training and helping companies deploy Swift on the server around the world. I haven't touched iOS professionally since 2019. I'm better known as being one half of the Vapor core team, and a lot of today's talk is based on the experiences that we had of trying to adopt Sendable in Vapor's code base in a non-breaking way. And spoiler alert, it took us a year, but we managed it. I'm part of the Swift Server work group and Swift Website work group, and the Swift Server work group is obviously very interested in making sure that Sendable is adopted across the ecosystem properly. I'm part of the server-side Swift team at Codeco, and I organize a couple of meetups and the server-side.swift conference. If you have any questions afterwards and you don't get to find me, feel free to reach me on all of the socials as 0xTim. I'm on Slack and other places as well. So why does Sendable exist? So in order to look at why Sendable exists, we need to take a step back and look at Swift itself. So as mentioned, Swift was introduced in 2014 at WWDC. And it had four kind of top-level goals. It was supposed to be safe, modern, fast, and interactive, in that order up there. Because I want to focus on the third one, which is the safety. Because Swift has a real focus on safety that makes it a really great language for many, many use cases. So for instance, we have optionals, which means that null pointer exceptions are just not a thing in Swift. There's a whole class of errors that you get in other languages that just do not exist in Swift. Swift has got really good memory bounds checking. So when you're reading, writing types and copying things, unless you're doing unsafe stuff, generally the compiler will stop you doing bad things. Whereas some other languages will just consume as much as you want, and if you forget to tell it to stop, tough luck. Swift also has explicit error handling. So if the function that you're trying to call throws an error, you have to handle that there and then, either by wrapping it in a do catch, by calling it with try and bubbling it up, but you have to be explicit about how you handle that error, which makes it very clear as to which functions are going to throw errors and how you're going to handle that at the call site. Other languages, do they throw errors? Don't know. Give it a go. And Swift has type checking. Swift's strongly typed and statically typed, which means when you're passing types around or when you're calling types, you know that that type is that type, and that's guaranteed by the compiler. And this is very different to some other kind of dynamic languages where you kind of at runtime decide if it's the thing. And all of these kind of features of Swift just remove entire classes of errors that make Swift an extremely safe language which reduce crashes. And Swift's whole ethos is to stop undefined behavior. And I'm not saying stop all crashes, because sometimes crashing is the right thing to do. For instance, if you're writing a banking app and you're discovered you're running on a jailbroken device, crashing might be the safest thing to do. Or you're the Swift runtime and you see you're in some weird memory exception error, the safest thing to do is to crash out. But we want to stop those undefined behaviors from ever happening. And it's part of this kind of ethos of modern languages of the shift-left approach, where instead of having all these issues at runtime, we want them to happen at compile time, so we can't even get them past CI. And we don't get to the instance where you ship an app to the App Store and then have a massive problem and you need to revert it. And in the iOS world especially, that's quite a painful process because you have to go through App Store review. But there is one kind of big class of errors that Swift mostly, certainly in Swift 5, is still very susceptible to, which is data races. Now, many of you may have seen something like this, where you have an exec bad access error, where you're doing something and trying to access things badly, and this will crash. And the reason for this is because you might have two pieces of code, two threads, trying to access a shared resource at the same time. So if you have two threads or two instances of code trying to write or read to the same shared resource at the same time, this is bad. This is undefined behavior, because what do you do in that instance? And the safest thing to do is to crash out for the Swift runtime. And this is what a data race is, essentially. And this isn't exclusive to just Swift. Almost every other language has this problem. So for instance, here's some documentation for Boto, which is the AWS SDK for Python. And if you go to one of the sections, and then go to one of the chapters, and then go to a page on that chapter, and scroll right down to the bottom and look at one of these subheadings called multi-threading or multi-processing with resources, you'll see there's this very single sentence that says resource instances are not thread safe and should not be shared across threads or processes. And it's up to you as a developer to read the documentation, which, face it, that doesn't happen, but to understand this context and be aware of the context when you're doing code reviews and calling it, and make sure you're doing it properly. And it's your responsibility to do that as a developer. And I've heard this quite a lot with people complaining about, especially when Swift was first introduced with optionals and stuff, and now Sendable and thread safety, of, I know what I'm doing, I'm not going to make mistakes. Well, spoiler alert, you are. And you might not, but people you work with will, or you might miss something in code review, and it's very easy to make these mistakes happen. But why? Why is it our responsibility as humans who always make mistakes to spot these errors and know about these things? Why, instead of reading the documentation or having this inherent knowledge or getting things spotted in code review, why can't we get the compiler to tell us when we're doing something that's inherently unsafe? Which leads me very nicely onto what Sendable is, because that is exactly what Sendable is. Sendable is the compiler telling you when you're doing something that is unsafe with data. So the proposal, Swift Evolution proposal was 302. You can go and read it on GitHub. I highly recommend you do, because it provides a lot of context about what's going on. But the kind of elevator pitch of Sendable is Sendable provides compiler guarantees of data safety in concurrent environments. So the compiler will make sure that you're not doing anything that will result in a data race and reduce crashes and fix all of these runtime errors that we're seeing. It's kind of like Rust memory safety in that it's not at all, but it has very similar goals. The implementations are entirely different, but the top-level goal of eliminating data races is the same. And you can kind of think of Sendable as thread safety. So if something's marked as Sendable, it's thread safe. Now, there are compiler engineers and Swift engineers who get very annoyed when I say that, because tasks and threads are not the same thing, but they are. And for all intents and purposes for this talk, and the way to conceptualize it is just think of a task as the same thing as a thread. So if you see Sendable, think of thread safety. And it goes back to this ethos of shifting left, of removing all of these runtime crashes when you do something that's unsafe and turning it into a compiler error. So how does this work? Well, Sendable is just a protocol. You can see it in the standard library. You can see it defined. It's a very special protocol, but it is just a protocol. But it does have lots of hooks in the compiler to do all kind of special stuff. And you can kind of think of Sendable stuff as like an onion. It's built on layers. So if you have a Sendable type, anything using that Sendable type can also be Sendable. And anything using that can also be Sendable, and so on and so forth. And it can kind of feel like you're pulling a very, very long string. It's the same with error checking in Swift. When you mark something as throws, that bubbles up everywhere, or with async await as well. You have to be explicit about handling it, but it is for good reason. So if we look at what the compiler does, let's say I have a struct called addressbook, and I'm going to mark this as Sendable. So when the compiler comes along and starts to compile this code, it sees, okay, well, you have a single property there called people that's an array of person. I know array is Sendable because it's defined in the standard library when the elements that are part of that collection are also Sendable. So let's go and have a look at person. So I'll go and look at person. Person is also marked as Sendable, so that's good. And it contains two properties. It contains a date, which again is Sendable in the standard library, and contains this data, which is of type person data. So we're going to have a look at that. Person data is also marked as Sendable, so that's good. And it has three properties. It has a name, which is a string, which is Sendable in the standard library. It has the age, which is an int, and that's Sendable in the standard library, and the phone number, which is also a string. So the compiler can see that all of these properties are Sendable, so therefore person data is Sendable. And because person data is Sendable, person is Sendable, and because person is Sendable, addressbook is Sendable. And that's why we kind of have this bubbling up of sendability throughout our code. Now, most types in the standard library and foundation are now sendable these days. So things like dates and ints and strings and doubles, they're all sendable because they are structs, essentially. And structs and value types, including enums, are sendable by default. Because in order to mutate them, you have to make a copy of them. So if you're trying to do stuff with structs, if you want to mutate two different types, you end up having to copy them, and therefore it's safe. Structs are actually implicitly sendable within the same module. So if you're working in an app or a Swift package, that sendability is implicit inside that module. If you want to make your sendability public, you have to explicitly opt in, because if you added a type that wasn't sendable to your struct, that means it's no longer sendable, and that's a breaking change. So in order for it to be publicly sendable, you have to explicitly opt in to sendability. Because it's a protocol, you can use protocol composition and make protocols conform to sendable, and then anything conforming to this protocol will also be sendable. And the same works for generics as well. If you have a generic type, then you can make that sendable as long as the generic type itself is sendable as well. And the same with closures. You can mark closures sendable with the @sendable annotation in the same way that escaping works, and then you can pass around that closure as sendable, and that the compiler will also infer that things going in and out of that closure are also sendable and safe. So that covers about the 90% that we saw yesterday of migrating to Swift concurrency. The really easy stuff. If you have structs, if you have enums, mark them as sendable, you're probably fine. What about reference types? Well, in the very simple case, it's quite easy. So if you have a class that's marked as final, that has immutable properties that are sendable, then the reference type class is also sendable, because there's no mutation that can be possible, so therefore it can be sendable. After that, things kind of go downhill a little bit, unfortunately. So let's imagine I have a class called person that has 3 mutable properties because I want to use reference semantics. Reference semantics are a good thing in some use cases, and I want to be able to use them. How do I handle this type? And this is kind of where things get really awkward and annoying. But you do have a few options. So if I have a class here that's an address book that contains an array of persons, in order to make this sendable, option number 1, just whack main actor on it, problem solved. And for some use cases, if you're doing this with kind of main actor stuff, doing Swift UI stuff, it might actually be the right approach. Option number 2, kind of do it properly and use an actor. For a lot of use cases, actors are the right thing. But they do come with their downsides. Number 1, it changes the API. So if you're accessing functions that talk to internal properties, they now need to become asynchronous. And they're not the right solution in every other scenario. Option number 3 is do the kind of actor synchronization stuff manually. So in this instance, if I can get my thing to work, there we go, I have a lock. And then every access to the person array is done via the lock. And this ensures that when you're doing stuff concurrently, any access to that people array can't be unsafe because I'm handling the lock myself. And then because I'm doing this locking myself and the synchronization myself, I can use @uncheckSendable. And @uncheckSendable is kind of like you telling the compiler, trust me, I know what I'm doing. It's similar to like force unwrapping. It's the way of the escape hatch for sendability. However, be very, very careful about using uncheckSendable and only use it as a last resort and be very sure about what you're doing. UncheckSendable removes all sendable checking for the entire type. So whilst in the example we had there, each access to the array there was done via a lock, someone might come in a future PR and add an access that isn't done via the lock, and therefore your code is now unsafe, and you might introduce a data race. In fact, this code is actually already unsafe. Can anyone spot why? Shout? Nope, the initializer's fine. Person's a reference type here. And it means someone else could hold a reference to the person and mutate that at the same time. So, to demonstrate this, let's write some code. So I have an address book. I'm going to create that. I'm then going to create a person, Tim, 99, phone number. I'm then going to add that person to my address book. And then I'm going to pass my address book off to some function that gives it to something else. This is all fine up until this point. The problem is, I still have a reference to that person. I can then mutate a property on that person, and this could be done at the same time as something that store address book async has passed it to is also trying to access at the same time. And this is a classic data race, and this is where you get crashes. So be very careful about using unchecked sendable. In fact, if I made my type an actor instead of using unchecked sendable, in Swift 5 language mode and Swift 5 with strict concurrency checking turned on, you'll even get an error or a warning saying you're trying to access, passing an argument of non-sendable type person into an actor isolated context. So the compiler will give you a warning in Swift 5. Sorry, I should be clear. There is actually nothing inherently wrong with this piece of code, because I create my person, and then nothing else has access to it afterwards. So really, this is actually safe. And in Swift 6, we got Swift Evolution Proposal 414, which is about region-based isolation. I don't have a huge amount of time to talk about isolation today, but essentially think about it where you run your code. That's kind of where isolation kind of comes into. And we can see in this example here that because we don't use person anywhere else, that person is isolated to the context of that function, it's passed into our address book, and therefore this is actually safe, and this will not produce a warning in Swift 6. If I then try and do something stupid later, like mutate a property, you will get a warning because this, or an error in Swift 6, because this is unsafe. So you get the warning saying sending person risks causing data races. The compiler isn't always that clever, though. Let's say I had another function called addPerson, where I want to be able to pass a person to an address book separately, and I call await address book addPerson. The compiler can't check every instance of this call site, especially if it's public, and make sure this is safe. So if you try and do this, you will actually get an error in Swift 6, because this risks causing data race issues, even though it might be safe in some instances. However, another feature came in Swift 6, which is Swift Evolution Proposal 430, which is about the new sending keyword. And the sending keyword is about kind of annotating your code to say, add some constraints on where this is used to make sure it's only used safely. So if we go back to my piece of code, I can then mark person, which is a non-sendable type, with the sending keyword, and the compiler will enforce that any call sites to this don't mutate person after the fact. And this is a really nice way of working with non-sendable types in concurrency. I can then do this in a safe way. Sorry, I can't do this in a safe way again because you'll get a warning, an error, sorry. But sending works with return types as well, and it's a way of kind of just adding constraints to where your call sites are to ensure that you can kind of use non-sendable types safely in a way that actually makes sense when we know it's going to be safe. So it's kind of like compiler metadata. Let's say you want to work with safe mutable values. There are a few options. In the server world, we have a thing called neo-locked value box, but you can quite handily build your own. And this basically means that you wrap each individual property access with a lock, which is quite handy. If we then go back to our class, we can change these all to immutable because we're going through a lock, and the lock kind of has reference semantics, so it doesn't actually get mutated itself, the locked value box, sorry. And because all these now become immutable, neo-locked value box is sendable, person itself can be sendable. You can also do the same at the top level, and therefore address book now becomes sendable because they're all sendable. The other option is to use non-isolated unsafe, and this is kind of like the escape hatch for properties for sendable. It's very much like unchecked sendability, but it keeps that unchecked sendability scope to an individual property rather than removing sendable checking for an entire type. This is a kind of escape hatch, but use it very sparingly. Again, be very careful about how you use it, because it's very, very easy to shoot yourself in the foot. Okay, so most of this was covered yesterday, so I don't need to go through it. but I will give you a little bit of background into our Sendable journey in Vapor. I will re-emphasize Ben's point of don't panic. Your code is still going to compile. It's still going to work. You can still use Swift 5 language mode. You don't have to do anything straight away. I will caveat that, however, just because you don't have errors in your code and you've hidden all the errors doesn't mean your code is safe. Your code is still unsafe. The Sendable warnings are there for a reason. In Vapor, we had a number of really low-level, very horrible bugs that we couldn't reproduce. Things like my server crashes every 2 weeks. Here's a 4-line stack trace. Can you help me? And it's a data race issue. We can see it's a data race issue. We just have no idea where it's coming from. When we adopted Sendable throughout the code base and made sure everything was safe and did all the accesses via locks, all of these errors just disappeared. So our code was actually unsafe, and when we made it safe, we had data races that no longer existed. So be careful. Just because you don't have those things as errors doesn't mean your code is safe. So in Xcode, thank you, Antoine, for this screenshot. You can set the Swift 5 language mode in the compiler settings. If you're building a Swift package, you can, for Swift 5 packages, with the Swift tools version of Swift 5, you can set the experimental feature of strict concurrency checking equals complete. And this basically turns on all of the warnings you're going to get in Swift 6 and makes them warnings. If you're building a package with Swift 6 and you want to use the Swift 5 language mode, you can use the Swift language modes flag and set it to v5. If you don't do it, it will default to v6 and you'll get errors. And as mentioned yesterday, we'll have this kind of little journey where you turn it on and you get some warnings. You get some warnings. These are actually about a third of the warnings we had in Vapor because we managed to crash the compiler. But as mentioned yesterday, if you fix one thing, a lot of them disappear straight away. I'm not going to go through them because we kind of saw them yesterday, but we were doing some very stupid stuff that we should not have been doing. Like mutating captured reference types in closures randomly. But anyway, we saw those yesterday. The compiler these days is pretty good. Swift on the server has a habit of really kind of pushing the compiler. And this is a bug that we found in Neo's lock that took a little bit of discussion to work out where to go and how to fix it. But in Swift 6 and 601 and 602, things are actually generally pretty good. Okay, I want to talk quickly about maintaining your API because it is important. And I know it's a very painful topic and it'd be much nicer to just release breaking changes all the time. But those of us who write libraries kind of have to deal with it. So there are a number of tricks you can use to write backwards compatible APIs and adopt sendability. So if you have functions that take closures and you want to mark these closures as @sendable, this will all of a sudden produce loads of warnings for everyone using your closures if they're not doing it properly. You can use the @preconcurrency annotation on a function, and this will kind of silence a lot of those warnings unless they opt into strict concurrency checking, which is a really nice way of adding sendable closures without breaking all your client's code. You can also do @preconcurrency with imports. So if you're working with modules or dependencies that haven't been updated yet for Swift 6, if you do @preconcurrency import, it will hide all of the warnings that you get from that module. So if you're using this module's types and you'll use them in a sendable way and they're not sendable, this will hide a lot of those errors and makes it a lot easier to work with dependencies that have yet to be updated. One of the issues that we had in Vapor is that we have reference types that have mutable values because we want to use mutable values, but we can't make these immutable and we can't change them because that's part of our public API. So one of the tricks that we did was to introduce a private variable that had the actual neo-locked value box, and then we had our public variable became a computed property. And this way we didn't break our API and we still managed to make everything sendable. So it took us about a year, or took me about a year, I should say, to adopt Sendable in Vapor because we started in the Swift 5.9 era, and a lot of the tools and the tricks and the helpers that we have now didn't exist. So I think it was about 4 or 5 PRs of getting rejected before I finally landed something. And then it was another 6 months of adopting each thing incrementally until we were finally fully sendable. But we did manage to adopt Sendable completely and have 0 warnings with strict concurrency checking turned on without breaking our API at all. So it is possible if you are trying to do it. So a little bit of recap, and then I'm sure there'll be some questions. Sendable provides compiler guarantees of data safety in concurrent environments. It's a way of making sure that you don't have data race issues and getting the compiler to check those for you and flag them up before you even deploy your app. It's a really, really powerful feature that makes Swift very unique amongst every other language, apart from maybe Rust, and will provide and produce safer code and safer apps. There have been a lot of changes over the last 6 months or so. So if you were following the Evolution forums, you would have seen that there have been a couple of proposals over the last 6 months for Swift 6 on concurrency. These are all of the proposals for Swift 6 for concurrency. There are still currently proposals up now about changing isolation, default isolation for functions. So things are still a little bit in flux, but things are getting much better. Sending has made life a lot easier for dealing with non-sendable types. So start looking into it and start trying to adopt it because you will have better code. There's a really good video from Dub this year called Migrate Your Apps to Swift 6 that covers a lot of this. Recommend checking it out. There's the Swift.org migration as well, migration guide at swift.org/migration that covers most of this, and it is improving day by day. And then finally, a shout out to Matt's incredible blog that basically goes through every single proposal for Swift concurrency and explains it in very clear detail. He is probably the world expert on concurrency outside of Apple, so definitely check out his blog. I'll put the slides and put links in Slack later as well. Just let people take some pictures. Okay, thank you very much.
Thank you so much, Tim.
So,
I've learned.
Questions?
Yeah, questions. Who has questions? No questions. Everything super clear? Yes, in the front here.
So I have a question. I hope it's not too simple or anything, but what if I have an external module which is in theory sendable, but either me or someone else make an extension on this type that the extension will add functionality which doesn't conform to sendable? What happens then? Do I get an error, or it works but kind of?
So the only way, so modules themselves aren't sendable, but the types inside those modules are sendable. So the only way to make types that are currently sendable not sendable is to add new properties to them. You can't add properties in an extension. They have to be done in the actual source file. You can add computer properties, but computer properties don't count for sendability. So you won't be able to change a type to add new properties that aren't computer properties to make it non-sendable. So it won't work.
Okay, so computed properties don't count. Okay,
Correct,
thank
yes,
you. That's what I missed.
Cool.
Thank you.
Yeah, another question right next to him. Over here, myself.
Hi, and what about the Objective-C types and or even C types? Is there any way to make them safe?
Yeah, so when you start interrupting with other languages, it gets a little bit interesting. Write your code in Swift? No, so there are ways of scoping stuff properly. So there's the custom task executors proposal that is primarily aimed at running C code on specific tasks. When you can do that, you can make sure that you're not jumping across different tasks, and therefore you remove all issues of sendability or thread safety. So if you scope your C code to the correct tasks, then you don't have to worry about it, and you can use unchecked sendable in your wrappers. I don't think the compiler's clever enough to be able to work out sendable, but then that's the way to do it and make it safe. but essentially you're going to have to use unchecked sendable. You can add unchecked sendable in extensions to types you don't own. You can't add sendable, but you can add unchecked sendable to types you don't own. So if you have a type that is in a different module that you know is safe because you've done all the work, but it's, say, C or Objective-C, then you could add unchecked sendable and you remove all the warnings. But again, be careful, because here be dragons.
Thank you.
Beware. There was another question in the back down there, and then we have one in the front afterwards. All the way in the back. Whoever had their hand up in the back, is not still a question, or? No? Someone made up their mind. Okay, then in the front here with Gavin.
Yeah, so it's been a while since I've dealt with this, but I remember trying to get lazily initialized singletons to work with Sendable and running into lots of trouble. And I can't remember enough of the details to actually ask a great version of this question, but does that trigger anything in your mind about trying to get the common pattern of type.shared, where shared is not just a let constant?
Yes, singletons and sendable, or even singletons and data safety, don't really play very well nicely. You have to kind of work very hard. So yeah, singletons are generally bad with sendability. You can use the non-isolated unsafe annotations on the singleton, and it does tend to silence a lot of those warnings. There are some instances where the compiler doesn't catch that though, and there was a post on the forums about a month ago talking about singletons and stuff. I know that the Swift team and Holly have talked about making kind of top-level code that's generally quite safe better, but it's still a bit of an unsolved problem.
Do we have anyone else? Yes, all the way in the back.
Yeah, thank you very much, Tim. At least now I know that I'm doing the thing correctly. My question is this. Since Swift is pushing us towards the direction of Rust, do you think there is another way of doing this correctly, this data race safety check?
I'm not a compiler engineer, so I can't answer that completely, but I'd say probably no. Like, Rust doesn't have a great solution either. It's pretty, you have to you essentially end up manually managing memory, which is not a kind of thing that Swift wants to go down. So you either have two options where you manually manage your memory and make sure you deallocate properly, but Rust is much better at that, or you let Arc do it and have all these annotations to make sure you're not passing things. I don't think it's a bad thing. I think it does add a bit of complexity. I agree that there is as soon as you start adding concurrency to your apps, there's a big jump in complexity. And a lot of people are very unhappy with the progressive disclosure stuff of Swift, and it's breaking down a little bit. For me, the trade-off is entirely worth it because I tend to focus on apps that handle like tens of thousands of users at once rather than one user at once. So a data race issue that's going to crash the app is a very bad thing as opposed to, I'll just relaunch the app on my phone. So the trade-off for me is entirely perfect. But I don't have the knowledge to say if it's the best thing or not, or if there's anything better.
Thank you.
We do have time for one more question. Yes, the fine gentleman on the side.
If you had the chance to rename the protocol Sendable, would you take it and would you rename it to something else?
How long have you
My
got?
proposal is cross-threadable, but it's
Well,
it's
as soon as you start
horrible,
talking
yeah.
about threads, then that gets complicated because tasks are not the same with threads. I know I had the slide up there saying that Sendable is basically thread safety, but it's not because you can run multiple tasks on the same thread. And so if we start talking about thread safety and then you have, say, an embedded board that has one single thread, you would assume then that you would have no issue with data races, but that's not entirely true because when you have Swift concurrency, you have multiple tasks running on the same thread, that can still cause data race issues. So I think the move away from thread safety is the right thing, even though it's the easiest way to conceptualize it. In terms of a better name, I don't know. Naming things is very hard. I'm glad it's not my job. No, well, not for Swift itself, for Vapor it is, but yeah. I think Sendable kind of makes sense when you start adding sending and that kind of stuff in. Sending makes sense with Sendable. Whether Sendable makes sense on its own, I will leave that as an exercise up to the listener.
Very good, very good.
Thank you very much.
Thank you so much, Tim.